So Z1 and Z2 satisfy this equation. And argument of Z1 minus Z2 is pi by 4. You want imaginary part of Z1 plus Z2. So let us first simplify this equation. Z plus Z bar is equal to 2 times mod of Z minus 1. If Z is X plus Iy, you know that the conjugate is Z bar, which is X minus Iy. When you add them, Z plus Z bar is 2X. So LHS is 2X. In the right hand side, you'll get 2 times mod of Z minus 1, which means X plus Iy minus 1. And that is same as 2 times mod of X minus 1 plus Iy. Now cancel this 2 on both sides. And then you can write X is equal to, what is the modulus of a complex number? A plus IB root of A square plus B square. You will get root of X minus 1 whole square plus Y square. Squaring on both sides gives you X square equal to X minus 1 whole square plus Y square. And if you actually simplify this, you may get a parabola. So that is X, Y square equal to X square minus X minus 1 whole square. If you simplify the right hand side, it will be A square minus B square. A plus B would be 2X minus 1. A minus B would be 1. So it actually gives a parabola. So Z lies on a parabola. And Z1 and Z2 satisfy, it means they are points on parabola. So Y square equal to 2X minus 1 is the locus of Z, you can say. So let Z1 equal to X1 plus Iy1. Z2 equal to X2 plus Iy2. So Z1 and Z2 satisfy this equation 1. Therefore, you can say Y1 square equal to 2X1 minus 1 and Y2 square equal to 2X2 minus 1. Because X1, Y1, X2, Y2 should satisfy this equation. Now just subtract them, you'll get Y1 square minus Y2 square equal to 2 into X1 minus X2. And if you factorize this, you will get Y1 plus Y2 into Y1 minus Y2 in LHS equal to 2 times X1 minus X2 in RHS. Now let's go back and see they gave a condition that argument of Z1 minus Z2 is pi by 4. Let's use that. So now we have argument of Z1 minus Z2 is pi by 4. So basically what is Z1 minus Z2 when you subtract, it is X1 minus X2 plus I times Y1 minus Y2. So since we don't know whether the real and imaginary part are positive or not, we'll take the first case. Argument is tan inverse of Y1 minus Y2 by X1 minus X2. That should be pi by 4. So therefore, Y1 minus Y2 by X1 minus X2 should be tan pi by 4, which is 1, which means Y1 minus Y2 is same as X1 minus X2. Now, if you are applying this condition here, what will you get? Y1 plus Y2 into Y1 minus Y2 is equal to 2 times the X1 minus X2 there can be replaced with Y1 minus Y2 itself. Y1 minus Y2 itself. And you can cancel this because Y1 not equal to Y2. They're different imaginary parts of different complex numbers. So they are different. So Y1 plus Y2 is 2. But you know that Y1 is imaginary part of Z1 and Y2 is imaginary part of Z. So this sum is 2, or you can combine and write this as imaginary part of their sum. So whether you add complex numbers, find imaginary part, or find their imaginary parts and add them, it would be the same. So you get the answer as 2. So we can therefore mark C as the answer.